Okay, so I'm going to work on encoding some memory access operands now. So if I go to operandencoding.asm, and down here I'll start with some memory operand for MOV. So I'll just assume that the memory operands are going to be in the same destination spot. So the destination spot is still going to be RM. So here, for example, if I say just use some normal registers like RAX with different sizes of registers. So we'll do, for example, CL here. Maybe we'll use SP with DH or something, SP with DIL. We'll use, let's use another problematic one. So we got, for example, R12, and maybe with this one, we'll say just using R12 into R12. SP, R12, another problematic one will be RBP. So we'll, for example, maybe use an extended register here for this one. R13, why don't we just say RBP into R13 for this one. And then maybe we'll do, so we've got RAX, RSP, R12, RBP, R13. I think that should be enough. Maybe we'll make sure that we've got different register sizes here. So we'll say we've got 8-bit, 8-bit, 8-bit. We'll try and do 16-bit. So we'll say AX with, let's do RBX maybe. And then 32, so we'll say ECX or maybe I don't know, 14D or something. And then we've already got 64-bit here. So let's just go and generate this listing file again. So if I run a test on that should be a mismatch. So then we'll just take all of these and add them to the encoder tests. So each of these is an op MOV, and we're going to MOV different sizes. So I'll just put byte in here. I'll just put AX, AX, NA, NA, and then just change them all. So this one is, I'll leave these first ones because I need to transform these operands into memory access operands. So I'll just do these ones first over here. So this will be AX with CX. This one's going to be moving register DH with SP. This one's going to be BX and AX. This one is R14 with BX again. This one is SP with DI. This one is R12 with R12. This one is BP with R15, and then this one is R13 with BP. So this one is keyword because it's 64-bit MOV. Same with this, same with this. This one is a byte. This one is a D word. This one is word, and then these two are bytes. So the destination, the operand number one is a memory access. So I'm going to have this helper function M, which will transform it into a memory access operand. So I need that helper on here. So this will be M. This will just return a new operand, and all it's going to do is return O. But before it returns it, we're just going to wipe out the reg flag and instead add a mem flag. So this is now memory. So if I do that, this should fail all of the tests, and actually it's panicking. So so the high bytes cannot be used with a rex prefix on this one here. Oh wait, no, this is actually working. It's the one after this one, so RAXCL. So this one here, SP, cannot be used with the high byte. So that is because the SP register, let me just check this. So SP cannot be used with high. So we're getting a rex prefix here. Oh, okay, that's because it's a byte size. Because it's a byte size and SP has the RL flag, I need to check that this is actually a register as well, because I've changed the operand to a memory flag, so I need to make sure that this is register. And just to be sure, I need to make sure that these are also checking that they're actually registers as well. Okay. Okay, so now that correctly allows it, but we're getting the incorrect like ModRM and everything, because the top 2 bits are still being just hard-coded as a direct register. So here, I'll now need a mod byte. So if we say, for example, mod can start out as address directs. But if the RM, because RM is the only operand that can actually be memory access, if RM is memory, then we'll just, you know, for example, assume that it's indirect. Yeah, we'll just assume it's indirect for now. So that's made a few of them pass. We're now getting correct ModRM. So for example, this ModRM is correct, but in this case, we're using SP, which can only be, as a memory access, can only be encoded using a SIB byte, which we don't have right now. Same goes for this one, same goes for this one. And then BP and R13 here can only be encoded using one of the displacement rows. And obviously we'll want to choose the smallest displacement because we don't have any displacement right now. So these have a 0 displacement on the end. So I need to do some checks for ModRM and displacements. Maybe if I get the displacements out the way first, because I think those will be a bit easier. For example, if we're using BP or R13, then we will want to make sure that we're adding a displacement if it's memory. So for example, we could add another flag in here to say membp, and R13 could also take membp, and then it's easy to check whether it's a special case memory. And we'll need a special case for SP as well, so we may as well add this in here at the same time. So this will go for SP and R12, because these ones need the SIB and the other ones need displacement. So in the case where we've got RM as memory, then if it's not a displacement, so we need a way to transform an operand into having a displacement. So if we say, for example, D here can just return an operand, and we'll take a displacement, which will be disp int32, because displacements can be signed. And then what we'll do is we'll just add a flag of disp return O, and the value, the bottom part of the value is used for like the register index and stuff, so I can't use that. So if we just use the top 32 bits as the displacement, so we'll just clear any displacement bits here. So this will be OX FFFF, and then 0, 0, 0, 0, and then or in the displacement. So we'll say disp is going to convert to a uint64, and we'll shift this up by 32. So the top 32 bits of value will be the displacement. And then we'll just have a helper to get the displacement out. So we'll say disp is int32, and this will basically be return o.value shifted down by 32, and we'll convert that into an int32. So if, oh, and I also need to add the disp flag as well. So if RM is membp and it's not already a displacement, then we will try to make it a displacement. So if membp and it's not a displacement, then we'll want to see which, how big should the display, oh, in this case it's not a displacement anyway, so actually it's fine. We can just say rm equals rm.d, where we pass in 0 for the displacement. Then down here, we can actually decide on the mod. So we can say if rm is a displacement, in this case, then we'll want to check the displacement. So we'll say rm.disp. If it's small enough to fit into a byte, then we'll say that it's disp 8. Otherwise, we'll say it's disp 32. So if math.min int 8 is less than or equal to the displacement, and the displacement is less than or equal to math.maxint 8, then mod will change to address disp 8. Otherwise, we'll change it to 32. So that sets the mod. And then the displacement comes after the mod rm and sib. So we'll do that down here. So we say if rm is a displacement, because rm is the only one that can have a displacement, because displacement is related to memory. Then we'll basically want to append the displacement bytes based on the size. So in this case, maybe what we'll do is say, just base it on the mod for now. So we'll do a switch on mod. We'll say that in the case of it being displacement 8, then in this case, we'll basically just want to append a single byte. So e.code equals append e.code. And this will basically just be the displacement of rm. But converted into a byte. Otherwise, if it's 32, then we'll want to do something like e.code equals, I think it's binary little endian, append uint32. So this will take e.code, and then we'll take uint32 from disp. Binary.little endian. Okay. All right, so that's taking care of BP and R13. So now we just need SP and R12 to be sorted out. So in this case, SP and R12 can only be used in memory access if you select them through the SIB byte as the base register. So you know, in the ModRM table, this would be SP. This would be SP, this would be SP. They would also be R12, but this means that you have to follow with a SIB. And then down in the SIB table here, we don't want any sort of index. so, you know, if it was SP, you couldn't select it with this anyway, because this is none. So you have to select it as the base register with no index. So in that case, it's always no index here, along with the SP, so it ends up being 24, which is why in the test output here from NASM, we see 24 in each of them, because it's selecting that SP through the base register. So right now, the SIB comes before the displacement. So right now, I think what we'll do is we'll just say that if RM is memory and it's mem SP, then in this case, we'll just append the SIB as like a hard-coded 24 at the moment. Okay, and that makes it pass. So we'll get into more of just making this a bit more general and dynamic as we go through more operand cases.